So this leads us into MapReduce. So I should have minimized it. There we go. Okay, so MapReduce basically is, like I mentioned, like a philosophy of programming. It basically is doing two jobs, is literally its name. Like computer scientists are probably like the most like lazy namers. So they said, oh, this philosophy of like, we do this map and then reduce, we'll call it MapReduce. Simple stuff. Okay, so basically there's two main steps, the mapping part and the reducing part. However, I don't really like that phrasing because you can tell here, like for example, this picture from the curriculum, you'll notice that there's a split part and the shuffle part. And that's because we usually consider this split and mapping part to be the mapping section, and then the shuffle reduce the reducing section. But I think it helps to split it up into these four parts. But just kind of be aware of this. This is best for clusters. Basically, each one of these parts will be a worker, essentially a different part of the computer or a different like CPU that can process this part. And this can make it a lot easier. And this is actually very similar to a lot of like computer science algorithms where you can basically parallelize it by essentially say, well, okay, instead of doing, this long, big task, I can split up this task into very, very simple parts. If you guys remember way back when you probably learned recursion, like in section like 12-ish, that's so a long time ago for us. But in recursion, you're basically splitting up into the smallest, simplest part. And then once you find the simplest part, then you kind of iterate up. It's kind of similar to that in the sense that you're trying to make it as simple as possible. But the way you build up complexity is essentially just have many of them. Okay. So again, going from here, I guess I'll give an overview of like your MapReduce of what this looks like, right? So you have like all your words. So if you wanted to see, how many like words occur, so lion, tiger, how many times lion occurs and all that stuff, you have this long list of words. Then you can split this up and say, okay, go ahead and take this text file and you split this up into different workers. So you basically say, all right, CPU number one, you will have these words, lion, tiger, and wolf. So usually it's split up by like lines or something like this, right? And say, okay, and you will have lion, giraffe, and you will have giraffe and penguin. And for the most part, you want to make it relatively equal. You don't want to give like one of them like 50% of all the items and then everyone's get like the rest of it. So this is where we kind of make it equal, but it doesn't have to be exactly equal. But if you make it approximately, then they'll hopefully finish at the same time, which means it's opened up for more resources. Okay, so basically this is the splitting part. Essentially, you're just giving the information to each CPU. Then each part goes, okay, takes the stuff that you gave it through, the worker, and takes it and maps it out. And this mapping step basically, again, remember this is more like a philosophy than like an actual way of programming. Essentially, you determine what is the thing that you're going to do. So for example, if you wanted to know how many times lion occurs or how many times tiger occurs, basically all you're saying, well, okay, lion occurs one time. So this would be like a tuple representation. Okay, so lion one, tiger one, wolf one. So this you can see is pretty simple. Like there's not a whole lot of like step within here. That usually tends to happen with map. They can be a little more complicated, but the important part is that you don't want it so complicated where it's doing a whole lot of work. You kind of want it to be able to process this very quickly so you can pass on to the next thing. Okay, so after this point, every CPU has basically mapped over to some kind of tuple, basically its key and its value, important part, right? And after that, we're basically going to pass it over and say, okay, it's called shuffle, which I think is super confusing because it's not really shuffling. It's kind of like unshuffling. So you can see basically, there's not really arrows, but usually I've seen classically drawn where these arrows will point to each part. And basically each CPU will be assigned, like, okay, give me all the giraffes. Okay, and I'll basically pass all those on to the giraffes. Give me all the koalas. Okay, give me all the koalas. And basically they pass it on to this part. This is kind of like the slower step, but hopefully it's not going to be too long because we've already mapped them out and it's going to make the next process very quick. So we pass those over, and then once we pass it over, then we can process it, basically reduce it. It takes their whole thing, and this usually is a very simple process. Okay, a lot simpler than like trying to get this whole thing, reduce it themselves, and then reduce it to one thing and then pass into its final part over here. Okay, so that's kind of like the overview. I kind of wrote out steps explicitly. So your split step, you assign the task to each worker. Like I said, you pass and say, all right, you're going to take this data. The mapping section, basically you're going to map like what are you going to do with the stuff that you have on your split. So it takes in data from one form and puts it into another form. And usually that means a tuple, a key value pair. Okay, that's usually how you can kind of think about it. Basically, what is the key and then what is the value for that? So then later on, that key will be used to combine and reduce it later on. Okay, and then our last part, or not last part, our second last part is shuffling. Basically, it's a reorganizing step. to make reducing easier. So basically, instead of like having tried to combine this together and reduce these parts and reduce them again or something like that, we're basically repassing it over to make the reducing step a lot easier. And then our reducing part, basically it takes each grouping over there and maps and combines it into some smaller set, which can be combined with the full data set. Okay. Any overall questions about the concept of like how this MapReduce works? Okay, cool. One thing to note, this is a nice, neat example. You might not necessarily have one area, like one CPU actually processing all the giraffes. You might actually have a CPU have like giraffe and then also giraffes here. But that's okay because you'll have a giraffe 3 and then say giraffe like 1, and then it can combine it later on. The point is that it makes it a lot simpler to reduce it further. You also might have something where this might process, like if, like for example, let's say there's a lot of giraffes going through. There's like 500 giraffes, but there's like 3 koalas, 3 tigers, 2 wolves. It might split it up where we have multiple parts doing just giraffe and then one that might actually do koala and tiger and wolf all in one CPU. The point is basically it's trying to make sure, this is more of the resource management, you're trying to make sure that each part will process it and not take too long. So for example, if this one takes a long time to process and these are all done, you're again wasting resources, right? You want it to be done quicker. So that's kind of like why it splits it up in that way. Okay, cool. All right, so okay, that's kind of like all conceptually like what's going on. Any questions on like any of that stuff? Hopefully it feels pretty familiar then, like curriculum, you're like, yeah, get this through. Awesome.